Hello everyone, my name is Dilshan. In this video, I am going to discuss the security vulnerabilities I found the HouseCraft website and how we fix them. In my part, I identified three main vulnerabilities. First one is CSP failure to define Directive will no fallback. In the beginning, our website had no proper CSP rules, which meant the browser could load script from anywhere. This is risk because an attacker can inject malicious scripts. I solved this using the Helmet dependency. I configured the context security policy directive and allowed only trusted sources like Google APIs, Google Fonts, and self-hosted content. I also blocked inline script in production. By doing this, I made sure only safe script style and images can run inside the browser. The second vulnerability is information disclosure. Earlier, our web was showing detailed error messages, such as whether a user existed, database errors, or even stack. This given attackers too much information. To solve this, I created an error handling middleware. This middleware shows only safe and simple messages like invalid credential or internal server errors to the user. At the same time, the full error is logged on the server console for debugger. This way, developers get the detailed but attackers cannot learn anything useful from the responses. The third vulnerability is missing rate limiting in authentication. Without rate limiting, attackers could try thousands of login requests until they guessed the right password. To fix this, I created different rate limiter middleware using the expose rate limit package. For example, I added a general limiter for all APIs, a strict limiter for login, and a special limiter for registering, password update, and consultant creation. Finally, I called this middleware inside my routes and servers configuration. Now only a few login attempts are allowed and brute force attack are blocked. Finally, I added Google Authentication. I created a Google Client ID in the Google Cloud Console. Then I added a Google login button in the front end, which calls my backend API. The backend authenticate the user with Google Auth and redirect back to my website. This makes authentication stronger and more secure than weak passwords.
Hi, I'm Madusarani. I also found 3 security vulnerabilities in the HouseCraft system. Let me explain them briefly with the fixes. The first issue was with the authentication request. The login and session endpoints were not strongly protected, making them vulnerable to brute force and credential stuffing attacks. To fix this issue, I hardened the authentication endpoints. All login traffic is now enforced over HTTPS. I applied rate limiting for repeated login failures and introduced strong password policies directly in the user model. Additionally, I applied CSRF token. This prevents forked requests while logging suspicious login attempts, helps monitor and respond to abnormal behavior. These measures make it much harder for attackers to break into accounts through weak authentication points. The second vulnerability was in the property-related forms, which accepted input without validation. This allowed malicious script or NoSQL injections through fields like property title or description. To solve this, I added server-side validation using the Joy library. For example, property prices are restricted to numeric values, and titles must be alphanumeric. I also included sanitization, so harmful characters are removed before saving to the database. These changes ensure all property inputs are strictly validated and safe. My final finding was that the Firebase configuration, API keys, and project IDs was hard-coded in the front end, which could be misused if discovered. The fix I applied was to move Firebase configurations into a secure.env file, which is hidden from version control. I also updated the Firebase security rules, making sure that only authenticated and authorized users can access database resources. Additionally, unused services were disabled to minimize the attack surface. This way, sensitive details are no longer exposed, and Firebase services remain secure. Thank you.
Hello everyone, I'm Vihanga. I identified 3 vulnerabilities in our application. The first issue was identified by our security scanner, user controllable HTML element attribute attacks. This means malicious users could inject dangerous HTML attribute like alert functions into our application, potentially executing malicious JavaScript in other users' browsers. For example, if someone registered with name called alert like XSS attack, this could be executed in the browsers and compromise user data or session information. Here, how we solved it with the multi-layered defense approach. First, we create a comprehensive XSS protection middleware in XSS protection middleware.js. Second, we applied it in our authentication controller. Finally, we implement it in rate limiting to detect and block XSS attempts and harden our content security policy in server.js. The second issue was that our JW token were being stored in local storage on the client side, making them vulnerability to XSS attacks. If an attacker could inject malicious JavaScript, they could easily steal these tokens using simple code like local storage.getItem token and impersonate users. This is one of the most common causes of session hijacking. Once stolen, this token could be used to access user account, steal personal data, or perform unauthorized actions on behalf of legitimate users. Here is the how we implemented secure cookie-based token storage. First, we moved token storage to HTTP-only cookies in auth Then we updated our authentication middleware and token handling went from front end. The third issue was that our application leaked protection against clickjacking attacks. Without proper headers, malicious website could embed our application in invisible iframes and trick users into clicking on hidden elements. Here, how implemented comprehensive anti-clickjacking protection in server.js. Then we implemented content security policy. Those are the vulnerabilities identified by me.
Hello, I am Malmi Nadee. In this video, I will explain three vulnerabilities I identify in our application and how I fix them. The first one is user agent fuzzer issues. User agent fuzzer tries to sending unusual or the malicious headers to find the weaknesses. This can allow attackers to inject code. To fix this, I added middleware that validates and sanitizes the user agent headers. It rejects headers that are too long and the block suspend patterns like script or the SQL keywords, and it's remove the dangerous characters. And I also added rate limit to block repeated suspend request. Now the server is protected against the malicious user agent headers. The second one is fixing overly permissive CORS in the server configuration. Initially, our backend accept requests from any website, which is risky because malicious sites could access sensitive data using the user credential. To fix this, I created whitelist of trusted domains like our local development URLs and the production frontends. For example, in this code, we define allowed origin like this. Then I update crow configurations to allow request only from these domains. And I also limited allowed HTTP methods and the headers and the credentials to ensuring only authorized frontends can communicate with the backend. The third one is fixing weak password policy in the user. Originally, the system allow weak password which is make accounts vulnerable to brute force attacks. To fix this, I added rules in the user model to enforce strong passwords. Now, a password must have at least 8 characters with uppercase, lowercase, numbers, and the special characters. I used bicrypt to hash password before saving them. This means even if someone gets access to the database, they cannot read or use the password directly. I fixed three key vulnerabilities: user agent fuzzing risk, over permissive CORS, and the weak password policies. These changes protect sensitive information, prevent unauthorized access, and make user accounts more secure, improving the overall reliability of our application. Thank you.